Hello students, welcome to the 5th module of the C programming. In that one, we are learning the subparts which is the unions. First of all, let us see what is union. Okay. Union is a collection of variables of different types. As we have learnt in the previous sessions like arrays, in which the content of the array was belonging to the same data type. For example, I have taught you about the strings in which the content of string was belonging to the data type characters only, right. So, I was not clubbing the characters with some other data type, but in the union it allows us to club the different data types together. We have already learnt one more data type called as structures, which was also consisting of different data types information together. Right. Today we will learn what is union with the comparison with the structures. So, the definition of a union says it is a collection of variables of different types. Meaning is what? In one union I can have multiple data types, that is I can have the data with respect to characters, strings, the integers and the decimal point. Suppose I want to store the information about a particular student. In that scenario, I will be storing with respect to a student, I store his name which is a string, roll number which can be an integer, the marks scored by him again can be the integers, average scored by him will be the floating data, right. But when I want to look into one set of one student's information, it is a combination of string, int as well as the decimal or the float information. That is why the union is called as the collection of variables of different data types. As we say, it is a collection of variables of different data types. But the main constraint on the union is at one time I can access only one field of the information that is present in the union. That is, at a given time either I can read or write the roll number, I can read or write his name, or either I can read or write his or her marks code, or I can calculate the average. Means it can be thought of as a chunk of memory in which I am storing the different types. Means only one place is given to me, I will use it to first store the string information, second time the same memory is used by me to store the integer value, again the same memory location will be used by me to store the float value. The same chunk of memory will be used to store the values of different types here, right. So, when I say I am just using one memory location to store the different information, it says if I store the name, previously read roll number will be replaced, right. It is as good as you have just one box to keep the one item at a time, right. So, it is as good as you are sitting on a chair which has a constraint that only one person can sit, right. When you sit, your friend has to stand up, when your friend sits, you have to stand up, right. Similarly, the same memory location when it has to be used to store the information with respect to different data, the previously stored data will be replaced. Whenever the new data will be read, the previous value will be replaced. So, look here, to declare the union, what is required? Keyword union, a name has to be given to the union and the members of the union are to be declared, right. Each of them will have their own data type, their own name, data type, name. There can be n number of variables can be present in one union. So, let us take an example. Keyword union, name of the union is student, right, and the member variables are data type is integer, variable name is roll number, data type is character array, that is string, right, and the name of the string is name here, right. So, what it says, name is a string array which is capable of storing the 20 characters. Look here, to store one integer value I take 2 bytes. To store one integer value I take 2 bytes. To store one character, I take 1 byte. How many characters I am storing here? 20 characters. That's why the size of the name is 20 bytes. The size of the name is 20 bytes. So you should remember what I said in the previous slide. That is, union can be thought of as chunk of memory that is used to store the variable of the different types, right? But you can store only one field at one time. Either I can take the roll number or either I can take the name here. So size of the union is always the field that is capable of storing the largest data. So here if I compare the variable roll number with the name, the largest variable size is 20 bytes, which is the name. That's why the size of the union will be 20 bytes. The size of the union will be taken as 20 bytes because size of the union is the size of its largest field. The largest field is here name, because it is taking 20 byte. This one is taking just 2 bytes, right? So this same 20 byte is used to store the name, either to store the roll number. Only one field will be read at a time. So how to access the members of the union now? As we all know, always we are taking the help of a dot operator. How you use it, the structures. The same way we are using the dot operators to access the content of the union members. So for that one, what is required? Name of the union, dot operator, what member you want to read, right? Previously I had a union student. So S1 and S2 are the union variables. Now I can say S1 dot roll number, S1 dot name. Similarly S2 dot roll number, S2 dot name. Like this I can access the union members. So let us compare. We have learnt two data types. If you look at them, they look similar. That is, we have learnt about the structures which is capable of storing the different variables of belonging to different data types. The union also says I too am capable of storing different variables of different data types. So let us compare what is the difference here, right? Look here, to declare a structure I am using the word as struct here, okay. So point 1 is a structure variable. Point 1 is a structure variable. Here I have used the keyword point 2. So point 2 is a union variable. Whenever I am using the point 1 is a structure, point 2 is a union, right? It also has two member x and y. It also has two members x and y, right? So the size of the structure is the size required by all the members that are present in the structure. How many members are present in the structure point 1? Two members are present. This is also int, this is also int. To store one int, I require 2 byte, right? To store x and y, I require 4 byte of memory, right? But what the union says? Union says it gives only to access at the max one variable member at a time. So either I can store x or either I can store y, right? So the size will be just 2 byte here, right? Largest field, both of them are of the same data type. So here the size will be 2 here, okay. So that is the first difference. The second one is look here, since 4 byte of memory is allocated to me to store x and to store y, I can initialize my structure with 2, 3. So that 2 will be stored here and 3 will be stored here. But when I initialize my union like this, it is wrong, because at the max I have only 2 byte of information, 2 byte of memory location. Either I can store x or y. What am I doing here? I am trying to initialize both the members, x to 4 and y to 5 here. That's why it gives me an error, because it is illegal. I don't have memory only to store them separately. At given time, either I can store x or I can store y. That's why. So when I store x, y will not be present. Once I store the value of y, x value will be replaced here. Okay. So the next difference is, right, the next difference is, so here if I want to print the value of x and y, I can say, using the dot operator, I say p1 dot x, p1 dot y. What is present in x? 2 is present. What is present in y? 3 is present. So I can print x value and y value as 2 and 3. But is not the same thing will not happen with the union, because at the ones I can have only one value, right. Suppose if I write p2 dot x is equal to 4 followed by p2 dot y is equal to 5. Look here, in the same memory location initially 4 will be stored. When I execute this statement p2 dot x is equal to 4, when I execute it, the memory location will be containing 4 value. But immediately I have written p2 dot y is equal to 5. So this 4 will be now replaced with the 5. So if I print p2 dot x and p2 dot y, I will get the answer as 5, 5, because x value is being replaced by the y value. Since only one memory location is accessible at one time. Okay, so let us learn with a diagram here. So I have a structure called as point 1. Okay, so when the member variables x and y are created, separately they have their own memory. p1 dot y is here, p1 dot x is here, p1 dot y is having 3 here. When this instruction is executed, 4 byte, that is 2 byte is allocated. So if I print them separately, I can access them separately, I can print them separately. But look here, when the union is created, at the max only 2 byte memory is allocated to it. So when p2 dot x is also pointing to the same memory, p2 dot y is also pointing to the same memory, right. At the max they are having the 2 byte location. That's why when this statement is executed, it will be having 4, but immediately if I execute p2 dot y, this 4 now will be replaced with the 5. In the memory location only 5 will be retained. So let us take this small example to understand. I have a union. The name of the union is point 2. The member variables are x and y. In the main, I have created a variable of union with the name p2, right. So what happens in the memory? 2 byte of memory location will be reserved for p2 now, right. So when I say p2 dot x is equal to 4, 4 is now present in the memory. So when I say printf x coordinate as p2 dot x, what will be extracted? 4 will be extracted, and I am printing the value 4 here. Okay. So the third statement says p2 dot y is equal to 5. Now what happens? This 4 now will be replaced with 5. So immediately I am printing the value of p2 dot y. So what will be printed? 5 will be printed. Look here, Again I am printing p2 dot x. This time, since 4 is replaced with 5, it again prints as 5 only. 4 is not printed. Now next one is, I can have a union variable within the structure also. Since structure is a variable data type in which is a combination of different data type. We all know union is also one of the data type, right? So what I can have is, within one structure I can have a union as a part of it, right? Example is, I have a structure called as student. Within that, what I have is a union variable which consists of name and roll number, and marks belongs to structure student. Now this is union. This union is present within the structure, that is union inside the structure. I can have a union inside the structure. So what I have is, I have a structure A, okay. So what it has? It has two variables, integer marks and the name as character array. Second one is, look here, I have a union name. Within that I have made this structure as a variable member of union. What is the meaning? I can have structure within the union also. Union can be present in the structure. Similarly, structure can be a part of a union, right? So what is this one? This is a structure, and I have a structure variable within the union. Okay, to access this content of a structure, what I will declare now? I want the union variable yes now, right? Union variable yes, and a structure variable A is there. Yes dot A dot marks. Yes dot A dot name. I have to write union variable dot structure variable dot the member names. So that is union structure variable. Union structure variable, I will be accessing the members of the structure within the union. Next one is, I can have arrays of union also. Again, to declare the array of the union, what is required? Data type, name of the array followed by the size. The data type is union. Name of the union is points. What is the size of this array? It is 3. Right? So this is a union. I have a union with the name point, and how many variables are there? 3 are there, right? So within one point, what are the two data members I have? X and Y, right? I have X and Y. This is first union, second union, third union array. At the points of the 0th location X I have 2. At the 0th Y location I have 3. Similarly, points first index X and Y values are 4 and 5, and the third array will have 6 and 7. As we know, at one time only one memory location can be accessed, right? So if I want to print the content of these all as a output, so the output will be three, 5 and 5, right? So the output will be 3, 5, 7 it is, right? 3, 5 and 7, because at this location I have accessed the 0th arrays X location 2, but as soon as I execute this statement, this 2 is replaced with the content 3. So if I want to print points 0th location X value and point 0th location Y value, right? 0th location Y value, this is replaced already by the Y value, right? That's why I'll just print 3, 3 as the output here. both the values x and y will be pointing to 3 only. Similarly, with the first index also, I have read the value of x, but this x value is replaced with the content of y. That is why I am printing x and y both as 5 only. Similarly, with the second array element also, x value 6 is replaced with the content 7 here. That is why I have only the newly read value will be stored, the previous values will be replaced. The remaining content will be continued in the next session. Thank you. The next concept is nesting of the function. As the name says, nesting means something is present within another, right? So when we are using the word nesting with the function, the meaning is we are defining one function within another one. Here I am declaring S1 within the function F1, right? So F1 has some body. Within that F1 I am defining S1 here, right? So let us look here what this F1 is doing. F1 is a function which is capable of receiving two values which are of type double, right? So within the function F1 I am defining one more function whose name is S1. What it is doing? It is taking a single value and it is returning me the square of that one, means the same number will be multiplied with itself here. Okay, so what F1 is doing here? F1 calls S1 with one parameter plus S1 is calling with another parameter. Okay, so when this S1 is called, what it does? It does multiplication of same number, right? A will be multiplied by A. Again S1 is called, but this time with the argument B. So B will be multiplied with B here. So I get the answer as sum of squares of these two numbers will be written here. Nesting of the function means defining one function within another function. Thank you.